typical ASTM standards, the first three sections of ASTM F3338, the standard specification for design of electric engines for general aviation aircraft, are always scope, reference documents, and terminology. Scope and reference documents have a list of standards and other documents that cover additional information on the topic. The terminology sections contains terms and definitions. It is important that all personnel in the aviation industry use a common meaning to foster teamwork and avoid confusion. This section is divided into 12 parts that identify terms and their meanings. It may include a discussion of some terms or additional information. The full standard for definitions related to airworthiness design standards is ASTM F3060, Standard Terminology for Aircraft. The first two definitions we'll cover are electric engine and motor. This is to establish a common understanding of the terms and the difference between the two. An electric engine is a type of aircraft engine that converts electric power into mechanical power or thrust used for propulsion, including those components necessary for proper control and functioning. A motor is a machine that converts electrical power into rotational mechanical power. An electric engine is used to provide propulsion to an aircraft, but a motor is any electrical machine that converts electricity to rotational power, such as motors for the extension and retraction of landing gear. ASTM F3338 defines two different types of rated power: rated maximum continuous power and rated takeoff power. Rated maximum continuous power is the brake power available at the output for unrestricted periods of use. Brake power is defined in SAE J245 as the power available at the flywheel or other output member or members for doing useful work. This is one example of the many times that this standard calls out other standards. Rated takeoff power is defined in ASTM 3338 as the power needed at takeoff limited to no more than 5 minutes. Next, we discuss the definitions for two different duty types. The difference in these terms is how the load behaves in the operating range versus the duration. These are foundational terms that establish design requirements that are critical throughout the design process. The first term is non-periodic duty. This is when the load and speed vary while in the operating range. An example is the operation of a constant speed propeller that adjusts pitch during flight. The second term is periodic duty. This is when one or more loads are constant for a specified duration. De-icing boots on a propeller are an example of periodic duty, since they operate on a specific cycle that doesn't vary during operation.